Today I'll be talking about managing Python dependencies at scale from Apache Airflow. Let me introduce myself. My name is Jarek Potiuk. I'm a committer and PMC member of Apache Airflow. And let me just see if we can start the presentation from the. Is the presentation live? Oh, okay. Yes, here it is. Thank you very much. Okay, good. So, going back to the presentation. Thank you very much. My name is Jarek Potiuk. I'm an independent open source contributor and advisor, which means that I'm not employed by anyone. I'm just contributing to open source. This is a fantastic thing to do. I can recommend it to everyone. I'm also Airflow committer and PMC member, and I'm a member of Apache Software Foundation. You can find me on Twitter and GitHub. And what I'm going to talk about today, I'm going to talk about Apache Airflow because this is the project I'm mostly involved in, and that's my beloved open source project I work on. But I want to focus on the dependencies. So I'll tell a little bit about what Apache Airflow is, so that you know the context. I will explain what are the basics about the dependencies that you have to think about when you run a big project at scale, such as an Airflow is, and explain a little bit about why Airflow is a little bit different than most of the projects, and what kind of challenges it has, and what kind of solutions we apply to solve those challenges. And at the end, I would like to summarize all the benefits that we get from that, from applying the solutions that I will talk about. So Airflow. What is Airflow? We are at PyData Global, so it is all about Python and data dependencies. And data and processing. So you probably know the picture from a few years back from Matt Turk about the modern data stack, and you know that data processing is quite a complex subject, and lots of different things are involved. And you can see that there are all those different kinds of applications, components, processing tools, engines, whatever that you can use to process the data. And it's a lot of things to worry about. And from my experience, to explain what Airflow is to anyone who doesn't know Airflow is a kind of conductor. So I'm a choirist, and I've been singing for 30 years in a choir. So that's metaphor is for me very, very close. Like, conductor doesn't do anything. Conductor doesn't perform any tasks when the music is playing, when the orchestra is playing. Conductor just makes sure that all the instruments and all the people who are playing in the orchestra are playing in sync, that they are entering in the right moment, they are doing the same music together, even though everyone does its own small thing. And basically that's what Airflow is. Airflow is making sure Airflow is an orchestrator that makes sure that all those different components and all those different tools can work together and process your data. That's basically what Airflow is. It doesn't do much. It's just it doesn't do itself. It doesn't do anything. It just makes sure that others are doing their job. And Airflow, what is important and why we are talking about Airflow in PyData Global, Airflow is Python centric. So everything about Python, about Airflow is Python. Like 99% of code is Python, or the rest is JavaScript to display the UI, but everything else is Python. And our users are Python, our developers are Python, our maintainers work on Python. So Python is very, very much in the center of everything we do. The definition of all the processing that we do, or like whenever you want to orchestrate something, you have to write Python code to describe that. And this Python code generates the dependencies between the tasks. So that's all about Airflow. I will not talk too much about Airflow as an application. A little bit. I will talk about that a little bit. But first, few words about dependencies. You probably, when you are using Python, you are developing Python applications, you're probably familiar with having a lot of dependencies. Like Python, the strength of Python is all about dependencies, about the millions and millions, or maybe not millions, but thousands of libraries that you can use immediately. And that's why Python is so powerful. And to manage those different tools and libraries that you want to use, there are lots of different tools, lots of different ways how you can manage dependencies. You can see all the different things that you have to remember about dependencies, and everyone does it a little bit differently. Everyone has their own approach. There are a number of tools that can manage dependencies between those different libraries. So at the end, what you end up with usually is some kind of a mess or some kind of complexity, I would say, that you can manage different libraries different way. You can put some different Python version, different Python installations, virtual environments. Everyone has its own different approach there. And with a number of dependencies, with number of different versions, this gets complex very fast. And there are two approaches. There are generally two approaches to how to manage dependencies, depending on what you are producing, what you're building. Now I'm talking about the perspective of someone who is preparing and using an application. So you can either install an application in your environment or a library. When you have applications, you can install them in their own virtual environment, and those applications have to be installed like they are kind of driving the virtual end. So you are installing a UI application, and everything in that virtual environment is this application virtual environment. And there are different dependencies, different properties that you want from that application. For example, you want to install that application consistently over time. You want to install it today and tomorrow, or month or 3 months from now, and it should install it in the same way. Doesn't matter if other libraries that the application uses have been already released or not. And the application knows which kind of dependencies it wants to use. So in most cases, the application can simply use the pinned dependencies. So you can tell, okay, I want this dependency in this version, that dependency in this version, and that works pretty well. But then when you have a library, this is a little bit different story, because the library are usually installed by those applications. So you install an application, and the application requires some library, and this library is installed. So when you have the library, you usually get installed, this application gets installed in another virtual environment, not yours. And this virtual environment has to be able to install other dependencies in different versions. So you cannot pin the dependencies. You have to specify like what are the limits of your application. So at least Python OpenID, which is 3 something, but you don't specify the exact version. So you cannot pin those dependencies. Usually, you just specify the ranges that the dependencies should be in. From the development setup, this looks a little bit different, because when you are developing such a library or application, you usually want to freeze the dependencies at some snapshot, so that you can consistently run your tests, and you can repeat your installation, and so that you can avoid this works for me syndrome, where your co-developer or colleague developer has different dependencies than you. So you want to, as a developer, you want to turn those kind of dependencies that you have in ranges. You have to say you want to switch in some set of those pinned dependencies, which for you become, and this is the important term that I'm using quite often, like a golden set of dependencies. So you want to say, okay, right now we are testing and developing our application with this particular golden set of dependencies, which we keep, and our CI is using the same set of dependencies, the same versions, exactly the same versions. Because we want to have a repeatable process of running the tests, and it happens millions and millions, well, many times for Airflow, that some dependency release broke our tests, and we want to avoid that. We want to make sure that whatever we are running with is stable. And also, it has this challenge that you want to, from time to time, you want to upgrade those dependencies. So you want to get to a different snapshot of those dependencies, because security, because you want to get latest updates. but you want to consistently move these snapshots together for everyone who is developing the application. So those are two different things. Like application and libraries from the user's perspective look a little bit differently, because for application you want to have fixed set of dependencies, and for okay, something is okay, and for the libraries you want to have those ranges. But Airflow is a little bit different, because from the operations people perspective, when you install Airflow, you want to install an application. So you have a UI, you have the web server and the GUI, and with this web server, you can actually see you can actually see and run Airflow. But from the developer's perspective, Airflow developer's perspective is a little bit different, because in Airflow, you develop your DAGs as Python code, and you use the Python code as a library. Airflow has more than 70 PyPy packages, and each of those packages are integrating with different, those are called providers. Each of those packages integrates with different service. Like you have like Amazon, Google, and like 70 other different services that you can use. Each of them has different dependencies, and when you're a developer, you have to somehow manage the fact that you have all those dependencies installed. Okay, something happened with the presentation. Okay, we are back. Okay, thank you very much. So you have those 70 packages that you have to manage. Each of them has a different set of dependencies, and those different providers, as we call them, they have completely different set of dependencies, and we have to put them together. Sometimes you want to install Airflow and add the Azure provider, Google provider, Docker provider, Alibaba provider, and you name it. And all of those providers putting together all the dependencies, it's a lot. It's a lot of different dependencies. So eventually, what happens with Airflow, we have 630 right now, as we speak, direct and transitive dependencies. So those are the direct dependencies of all our providers and Airflow, and their dependencies, etc. So all these transitive dependencies are 630. That's a lot. That's why Airflow is quite a beast in that perspective. And it grows, it continues to grow, and we have to manage it somehow. Like last year, October, when I gave a previous, quite different version of that talk, it was 500, 550. So almost 100 or 80 actually during a year. So this is only going to get worse. It's not going to get better. So now imagine that, and now from the user perspective, you can take a look at how how Airflow looks like from the developer's perspective. From someone who wants to orchestrate all those different components, they actually write a Python code. So they are the real developers, Python developers, who want to use some libraries to achieve the task they have. We have some predefined things like the DBC operator in this case. This is an example of one of our operators, one of 3,000 of operators we have. But you can also write your own Python code and your own libraries and use your own dependencies. And sometimes you want to use dependencies which Airflow uses, but in a different version. And Python doesn't have a good mechanism for that. In the environment where everything is run, you can only have one version of library installed. So that poses some unique challenges from Apache Airflow, because just to recap, we have users who are developing, or maintainers who are developing Airflow. We have someone like admin people who are installing Airflow and want to make sure it's installed as an application that you can use. And you have DAG developers or Airflow developers who are developing the DAGs or the workflows as a Python code. And each of those users, we have to look at Airflow and installation from different perspective of the users who are using them. You have to look for how their different perspective looks like in case of dependencies. So what's up there for maintainer? So what are the needs of Airflow maintainer? like I'm one of the Airflow maintainers, so we have like 600 dependencies. Installing them at a given time as a like virtual env install, like usually you do, it's almost impossible, especially that we have different OSs like Linux, Mac OS, WSL. We are right now preparing Airflow to run on Windows natively as well. We have more than 200, more than 100 active contributors per month. So people who are actively contributing the code to Airflow. In total, we have more than 2,200 contributors. That's a lot of people. Everyone has their own environment, and we want to avoid works for me syndrome wherever you develop an application. So we want to have these snapshots. So we want every contributor from those 2,000 people have the same snapshot of all the dependencies, and that's a challenge to get that because of 600 dependencies and those different OSs, different environments. But we also want to upgrade. We want to upgrade quickly and consistently from security. So supply chain security is super important for in the recent world, and we want to make sure that whenever somebody releases new version, we update it. So on one hand, we want to have snapshots. On the other hand, we want to update as soon as possible, which is a kind of contradicting. And when you look at 600 dependencies we have, it's about 20 updates a week, 20 security patch feature breaking changes, 20 updates a week coming regularly every single week from all those dependencies. That's a lot. So upgrading this all manually and trying to tell people, okay, please upgrade because there is a new version, it's completely out of the question. Even Dependabot is out of the question because if you know Dependabot, it brings you like PRs to your software to automatically to your GitHub projects where you can update new dependencies whenever they appear. But we have 20 updates a week. This means 20 more PRs to review, to take a look, to merge, to run the tests. That's a lot. So that was the perspective of maintainer. Then now the perspective of Airflow deployment manager, so someone who installed the Airflow. So they want to take Airflow and install it now, today, and in 3 months, and it should work. It should be, it should just be the same installation. Whenever somebody releases new versions of packages or other packages, it shouldn't impact the way how Airflow is installed. They want to have some scripts like Docker file or some other like bash script, whatever, to automatically install Airflow in the deployment because they probably want to deploy it in multiple variants. But they also want to be able to upgrade and downgrade some packages they want specifically for their deployment. Like they have their own internal tools, they have other libraries they are using, and they want to make sure that they are installed in the version they want. So that's already contradicting with the snapshot approach that I told before. Then there is they want also to upgrade the application, to upgrade Airflow easily. So make sure when there is a new version of Airflow, like we are just now releasing 2.5.0, somebody has 2.4.3, they want to be able to easily upgrade to 5 and get all the dependencies that Airflow needs to be upgraded together and automatically. And some easy way to solve the conflicts if they have conflicting libraries. That was the perspective of somebody who installed Airflow. But there is the third perspective. So we have to, it's like different people with different expectations, and they have to manage all of them, is the user. So the user, which is like the developer, basically, who is developing Airflow workflows, they really want to have the no pinning of the application because they want to be able to upgrade and test new version of a library. So they want to be able to upgrade it in like whenever they want, at will. And they want to build their own libraries. They want to easily add new packages for the development. So the approach of application where it freezes and tells, okay, those are all that I need, those are the version I need, will not work. So you cannot put a requirement on Airflow. Please, in like these are the versions that we want to install, like most applications do, but we want to be able to have an open set of dependencies. But then connecting it to the way like, okay, we want to always install Airflow consistently, but the user wants to upgrade all the dependencies independently. This is contradicting, and this is the problem. This is the challenge that that make it so difficult for Airflow to come up with a good solution. But we have solution. I'll get to that. So another perspective is the contributor perspective. Have 50 builds a day. We have 2,000 contributors. We have more than 50 CI builds a day. And we always want to use latest dependencies for the security purpose, but we also want to give the contributors the snapshots so that we know which versions they will run their test in, and the other contributors have to run in the same version, so that we avoid the works for me syndrome. So like somebody has a different dependency, it works for him or her, and it doesn't work for another. And it's very easy to see to get the breaking change released by someone else that will break your tests. This happened to us many times, and those are very different breakages. Like Moto 3 release, 2.2.5.15, not even feature release, it just broke our AWS test completely. They just stopped working. So we want to avoid the kind of external influence on our contributors, because if somebody releases new version of package and all the contributors will suddenly start using and start breaking the PRs, it means that all the PRs are broken. And we want to absolutely avoid this kind of situation, because then everyone complains that things do not work for them and they didn't change anything, which we want to avoid. So all the PRs of our contributors, they have to use the frozen, the snapshot set of dependencies. And that also allows those contributors to see in the CI when the tests are running, to be able to very easily reproduce those tests locally. So they have to somehow know and somehow get in their local environment when they want to reproduce it. If I see failure on CI, how do I reproduce it locally? So solutions. The solution that we came up with using constraints. If you don't know constraints, the constraints is a very interesting feature of pip. You can specify not the requirements. So this is not the things that you install, but this is kind of instruction for pip, telling, okay, if you want to install this dependency, this must be this version. So this looks like a requirement file, but it just contains information. Okay, if you install this, then this version has to be used. This means that Airflow can have an open set of dependencies, so that it can be each dependency can be easily upgraded and downgraded independently. But on the other hand, when you install it, you have this very nice and straightforward way of installing the specific version of dependencies. We are not using any opinionated solution. We automatically keep those constraints in check. So for every version of Airflow and every version of Python, we automatically keep, and this is all fully automated in our CI. We generate a golden set of dependencies and we keep them, so that whenever you install, you have this way of very easily installing Airflow using constraints. They are kept as separate orphan branches. We have some tags in Git. So it's all kept in GitHub, as you can see from this URL. And pip is very cool for that, for actually running those, using the constraint feature to pull the constraint file directly from GitHub. We keep it separate branch, and we tag whenever we release the software. So this looks like that. So you have just a requirement file that looks like requirement file, but it's automatically generated, and you can see exactly when it was automatically generated from our CI. So our CI takes care about that. And the important thing is also, like this, those dependencies are actually updated automatically by our CI build. So our CI build has some canary build, like in main, whenever we merge a code, it just tries to upgrade all those dependencies automatically, run all the tests, and if the tests succeed, then it will say, okay, these new dependencies which got upgraded automatically, they are new set of constraints, and I'm pushing the new set of constraints. They will be used from now on, but only after all the tests pass. And this is like canary build that tells us, okay, there is a new dependency, it probably breaks our build, the tests are failing, so we don't upgrade. And maintainers can take a look at that and fix those problems, and maybe constrain the dependencies, maybe fix the problem in tests. Until they do that, this is not automatically upgraded, and all the people who are doing all the PRs, they are actually using the older set of constraints, which is kind of tested and frozen, and everyone is happy. No PRs are broken. This is actually super cool because then it automatically upgrades the version. As you can see, this is an example of such an automated upgrade that happens. So at single time, whenever all the tests pass, we can upgrade all the dependencies, all the 600 of them, which is cool. We don't have many PRs. They are all tested with our tests, so we know they are not breaking our tests. This is fantastic. We can automatically upgrade 20 updates a week, very, very easy. And we also have a nice Dockerized, I will not go into details because we don't have too much time, but we have a nice development environment that uses it. So this means that you can locally install the latest version of constraints in your Docker environment, which is like a snapshot of all the dependencies installed, very easily refresh and build all the tests. So if it breaks in the CI, then it will also be easily reproduced locally, and uh, this this development environment actually takes care about all the updates automatically. So what is the takeaway from that? What the constraints freezing that we implemented and constraints that we implemented, how they work. For contributors, they provide stable dependencies. For PRs, for developers, they contain flexible environment for development of Airflow. For deployment managers, they are introducing the way of stable installing Airflow. And for maintainer and contributors, they allow for reproducible CI errors, automated upgrades of security, and some sanity in managing such a big environment.
Yeah. Hi,
Yeah.
Jarek. I just want to mention. I think you're spot on time. We're pushing about. I think we're 3 minutes away from ending. So I think it's a good time to get to the Q&A if you're at that
Okay.
stage right now.
Okay. So I'm almost at the Q&A session. Just one thing. So if this setup is good for Airflow, this is perfect for big installation. Probably not very useful for small installations, but I think about in the future to making this PAP and standard. Because right now it's custom made completely, but we would like to make it a standard. So if somebody is interested and sees that something like that would be useful, I'm asking for like reach out to me, and I will be building a PEP initiative to build it. And now this is a time for QA if there are any.